Welcome back to my YouTube channel Grandpa Mathematics. Today we'll do some more problems on exercise 9.3. Given the family of curves, we'll form the differential equation for given conditions. So in this problem, we have to form the differential equation of family of circles touching the y-axis at the origin. So let C denotes the family of circles touching the y-axis at the origin. So let C1 be member of the family of the circle touching the y-axis at the origin. Let the center of the circle be a comma 0. What is the radius of the circle? Radius also a only. So equation of C, that is family of circles touching the y-axis at origin, is x minus a whole square plus y square is equal to a square. X minus a whole square plus y minus 0 whole square, that is y square. Radius is a only, so a square. So this is the given equation. Here only one arbitrary constant is there. So a is the only one arbitrary constant, and therefore we have to differentiate this equation once, and we have to eliminate the constant a. So before differentiating we will simplify this. This gives x square minus 2xa plus a square plus y square is equal to a square. Here we can write x square plus y square is equal to 2xa. Cancel. So from here we can get x square plus y square by x is equal to 2a. So the right hand side is a constant. So if we differentiate this equation, a will vanish. So differentiate this equation with respect to x, we get. So this is v square, then we have to write v square means we have to write v, then du by dx minus u into dv by dx. So this we have to remember to do differentiation. So differentiate with respect to x we get. So here in place of v we have x, therefore v square, so x square, then we are writing v, that is x. Now we have to differentiate the numerator. So if we differentiate, we will get 2x. Again, if we differentiate y square, 2y into y dash, because we are differentiating with respect to x, minus u, that is numerator, x square plus y square into dv by dx. V is x, so if we differentiate, 1 will come. So this is equal to, if we differentiate to a, there is a constant, we will get 0. So you can see x, if you x square into 0, 0 only will come. We'll multiply this. So 2x square plus 2xy dash minus x square minus y square is equal to 0. 2xy dash 2x square minus x square is plus x square minus y square is equal to 0 is the differential equation of a family of curves touching the y-axis at the origin, is the required differential equation. So in this problem, we have to form the differential equation of a family of parabolas having the vertex at origin and axis along the positive y-axis. So let C denotes the family of parabolas having the vertex at origin and axis along the positive y-axis. So let us draw the rough sketch of one of the member of this family of parabolas. So this parabola has vertex at origin and axis along the positive direction of the y-axis. So what is the equation of this parabola? It's nothing but x square is equal to ay, where a is a constant, arbitrary constant. So equation of C, that is equation of family of parabolas having vertex at origin and axis along the positive y-axis. Equation of C is, here x square ay represent the equation of family of parabolas. Not, this is only a one parabola in the one member in the family. Equation of C is x square is equal to ay. So in this equation we have only one arbitrary constant. Therefore we have to differentiate these ones and we have to eliminate the constant a. So differentiate with respect to x, we get if we differentiate x square, we will get a 2x. If we differentiate a into y dash will go. Now we have to see how to eliminate a. So one way is find the value of a here and substitute in this equation, or find the value of a here and substitute in this equation. So if we divide this equation by this or this by this, the right hand side, no, ay dash by ay, a will get cancelled. So we will divide 1 by equation 1 by equation 2 gives x square by 2x is equal to ay by ay dash. So here a will get cancelled and we will get y by y dash. So this gives x by 2 is equal to y by y dash. Now if we cross multiply this, x y dash is equal to 2y. So x y dash minus 2y is equal to 0 is the differential equation. So this is the answer. In this problem, we have to form the differential equation of family of ellipses having foci on y-axis and a center at the origin. So let C denotes the family of ellipses having foci on y-axis and a center at the origin. We will draw a rough sketch of one member of C. So this ellipse have foci on y-axis and the center at origin. Since the foci is on y-axis, semi-major axis length A and the vertex is 0, A, and the semi-minor axis length is B and the vertex is B, 0. Equation of C is equation of family of ellipses having foci on y-axis and center at origin is y square by a square plus x square by b square is equal to 1. So this equation have two arbitrary constants a and b. So we have to differentiate this equation two times and we have to eliminate the arbitrary constants a and b. So differentiate this with respect to x, we get, if we differentiate y square, 2y into dy by dx, y dash by a square plus 2x by b square. If we differentiate 1, there is a constant 0 will come. So now we can divide this equation by 2. So this simply becomes like this. Now we call this equation 2. Differentiate again with respect to x, we get 1 by b square is equal to minus 1 by a square into y double dash plus y dash square. We will substitute this in 2. We get y dash by a square plus x into 1 by b square. Y dash by a square plus 1x into 1 by b square. That 1 by b square, I am going to write these things. So minus 1 by a square. Then this will be y double dash plus y dash square. This one. Is equal to 0. So y dash by a square plus x is there 1 by b square. For that 1 by b square, this whole thing written for that 1 by b square, then is equal to 0 comes here. Now in this term, no, this is a first term, this is a second term, we'll multiply throughout by a square. What will get? Y dash plus x into a square get cancelled minus y double dash minus y dash square is equal to 0. So can I rewrite this as y dash minus x y double dash minus x y dash square is equal to 0. Normally in the differential equation double dash will come the beginning, so we can write x y double dash minus y dash plus x into y dash square is equal to 0. So this is the required differential equation. So this is one way of doing it. In this problem, we have to form the differential equation of family of hyperbolas having foci on x-axis and the center at the origin. So let C denote the family of hyperbolas having foci on x-axis and the center at the origin. Let us draw one member of family of hyperbolas having foci on x-axis and the center at the origin. We'll draw a rough sketch. So equation of C is because foci is on x-axis, it will be x square by a square minus y square by b square is equal to 1. In the last problem, we have seen the equation of family of ellipse was x square by a square plus y square by b square is equal to 1 was there. So differentiate this with respect to x, 2x by a square minus 2y y dash by b square is equal to 0. Because this equation has two arbitrary constants a and b, so we have to differentiate 2 times and we have to eliminate the arbitrary constants a and b. So like before, we will divide this equation by 2. So now, earlier what we had done, we had differentiated this once again and then we have eliminated the arbitrary constants. Now what I am going to do, I will take all variables one side, constant to the other side. So that means we can write this as x by a square is equal to y dash by b square, I'll write b square by a square. I'm taking b square here, a square, then y dash by x. A square I will take to the right hand side. We'll differentiate this with respect to x. So the left hand side, see this u by v form. What is the d by dx of u by v? V square v u dash minus u v dash. So in place of v we have x here. So it will be x square x into, you have to differentiate u. So this is again uv form. So put bracket y double dash plus y dash. If we differentiate this, again y dash will come. So I'll put y dash square, close this bracket, then minus u, whatever comes on the numerator, y dash, into differentiation of v. If we differentiate x, we will get 1. Is equal to, if we differentiate right hand side, that is a constant, we will get only 0. So this gives, we cross multiplying x square into 0 is 0 only. So this will be x y double dash plus x y dash square minus y dash is equal to 0 is the required differential equation. So in this problem, we have to form the differential equation of a family of circles having the center on y-axis and the radius is 3 units. So let C denote the family of circles having center on y-axis and radius 3 units. So let us draw a member of family of circles having center on y-axis and radius 3 units. We will draw only a rough sketch. So this circle has center on the y-axis and the radius is 3 units. So what is the equation of C? So in general, equation of circle is x minus h whole square plus y minus k whole square is equal to r square. That means this means this circle has center at h comma k and radius r units. In this case, center is at 0 comma a. Therefore, x minus 0 square whole square, that is x square plus y minus a whole square, radius is 3 units. In this equation, we have only one arbitrary constant a. So that means we have to differentiate this only once. and we have to eliminate the arbitrary constants. So differentiate with respect to x, we get this will be 2 times y minus a power 2 minus 1. Again, if we differentiate this, dy by dx is equal to 0. So again we'll divide this equation by 2. Now we have to eliminate a by making use of these two equations. See here, y minus a is here also y minus a is here. So we'll find the value of y minus a here in this equation and substitute in equation 1. So y minus a into y dash, so that is equal to minus x. Y minus a is x by y dash. So now we'll substitute x by y dash for y minus a here. Substitute in 1, we get x square plus, for y minus a we are substituting x by y dash. So x by y dash whole square, because y minus a whole square, this equal to 9. I will multiply throughout by y dash square. So x square y dash square plus x square is equal to 9 times y dash square. Or we can write this as x square minus 9 times y dash square plus x square is equal to 0 is the required differential equation. So in this 1 mark question, we have to see which of the following differential equation has this as a general solution. In all these differential equations, we have d square y by dx square. So first we will find d square y by dx square. So y dash is equal to c1 e power x minus c2 e power minus x. If we differentiate e power minus x into minus 1 will come. What is y double dash c1 e power x again plus c2 e power minus x. So this is nothing but y. So y double dash minus y is equal to 0. D square y by dx square minus y is equal to 0. So this is the answer. We need not write the full step. Following differential equation has y is equal to x as one of its particular solution. So in all these differential equations, we need y dash and y double dash. So y is equal to x. This gives y dash is equal to 1, y double dash is equal to 0. So all three conditions you have to use here. So again, this all not the 0, y dash is 1. So this all 1. And y is equal to x. So y is equal to x means minus x square plus x square cannot be x, it's not there. So this is also not there. We put y is x minus x square plus x square is 0. So C is the answer.